Hi guys, greetings of the day. Welcome to my YouTube channel for learning a subject called Fluid Power Engineering for 5th semester and Fluid Power Systems for 7th semester as per VTU syllabus. If you haven't subscribed to my YouTube channel yet, kindly subscribe. Also click on bell icon to receive the latest lectures as and when it is uploaded in my YouTube channel. Now let's start the session number 51, which is based on electro-pneumatic control. The different methods of actuation of control valves are as seen in the figure. Electro-pneumatic is a combination of electric and pneumatic control method. Electrical energy has certain specific advantages over all other forms of control energy. For example, the flow of current can be easily controlled. This property alone is sufficient to be performed in all control systems, including pneumatic devices. A pneumatic control system with solenoid operated valves may be electro-pneumatic system. An electro-pneumatic system may consist of a pneumatic driving element and electromechanical control part. And the electromechanical part generally consists of a solenoid controlled by the basic types of electrical switches, and they are as follows, like push button switches, limit switches, pressure switches, temperature switches, electrical relays, and contactors. Then we will have a small discussion on the next topic, that is called a solenoid. Push button switches, both the things. A solenoid is a electromagnetic device which converts electrical energy into linear mechanical motion. This mechanical motion is used to actuate the valves in fluid power system. An electromagnet is a temporary magnet. When an electrical current is passed through a ferromagnetic core, the core becomes magnet, developing attractive or magnetic force and gets demagnetized as it is de-energized. The proper working of electromagnetic device in general and fluid control valve depends on the reliability of the electromagnets. A solenoid consists of a T-shaped core or a plunger, a wire coil, and a C-shaped frame as shown in the figure. When the coil is energized by passing current, the frame gets magnetized and pulls the plunger towards it. When the coil is de-energized, the plunger moves back to its original position due to spring or the solenoid on the other side. If the power so if the sorry In fluid power solenoids are most often used to actuate direction control valves and are typically on or off switches. Solenoids are available for both AC and DC operation in all standard voltages. Next, we'll discuss the concept of push button switches. These are control members used to control or make or break electrical circuits of the solenoid operated valves. There are varieties of switches, that is nothing but the contactors, available, but the switches should have the following essential qualities, like should be good conductor and made out of a brass or a copper, and also should have insulated casing including the handle or button used to operate. In pneumatic system, push button type switches are used when electrical signals are input for manual operations of the switch, and the figure shows the single pole throw normally open, single pole single throw normally closed, double pole single throw normally open, and normally closed positions you can see. These switches are mostly of single, double, triple, and quadruple poles. These switches are also referred as momentary switches because they make or break contact only when they are held pressed. They generate arcs under heavy current, and hence direct energizing loads should be avoided. Then coming to limit switches. Switches which limits the motion of an object by breaking the contact, and hence the circuit is called as limit switches. Limit switches also performs the same function as that of push button type, except they are mechanically operated instead of manual. Varieties of operators such as cams, levers, rollers, plungers, etc. are available as limit switches, and some of the types of limit switch and their symbols is represented like limit switch, uh, NO, NC, and NO held closed, NC held closed. Then we'll understand the next concept that is called as relay. Relay is an electromechanical switch used to make or break mechanical contact between the electrical leads. This offers a simple on-off switching action in response to control signal. A small input voltage to the solenoid controls a potentially large current using the relay contact, and the figure illustrates the construction of a relay. Upon construction, it consists of a coil of wire wound around a ferromagnetic core, a movable arm called armature connected to a spring, a wiper connected to the armature, which makes and breaks the contact with electrical leads of the external circuit. And how does it work? We'll understand by this figure. When a current is passed through the coil, the ferromagnetic core is magnetized. This attracts the armature, which moves towards the core against the spring force, along with the wiper. Now the wiper make contact with the lead B, and the external circuit is closed, and the current passes through the external circuit. When the current to the coil is withdrawn or removed, the core is demagnetized and armature is pulled back by the spring, which in turn the wiper breaks the contact with terminal A, and hence the electrical supply is cut off to the circuit. Relay is normally open switch. These relays are sometimes called as contactors and are available to switch on current from mini amps to several hundred amps to the external circuit. And the figure is shown on the right hand side, the working and application of the relay. But it is having some of the disadvantages. One of the major disadvantages of such electromechanical relays are generation of spark at the wiper end and the terminals B and E. The spark so generated forms oxide layer at contact points of the wiper and a terminal A and B. This in turn increases the resistance and ultimately melts due to heat. Another disadvantage is when this is used to switch on and off a high AC voltage causes a large amount of electrical noise, and these noise may be picked up by microcontroller if any used, and ultimately the relay fails. By this I am going to conclude the session, and thanks for your patience listening. If you have any sort of doubts, feel free to use the comment section for further discussion. I will answer all your questions related to the topics covered. Don't forget to like, share, and subscribe. Have a great day. Signing off, Vijay Tawardhan.